is my implementation for the robotics academic task. That's the visual flow line task. This is the code for it. So I'm going to do a bit of explanation why the code is running. So let's start it. Takes a while to start running. Okay. Code has started executing and our car is moving now. Okay. So in addition to the two modules that were provided, that's that of the GUI and that for interacting with the hardware, which is the HAL module. I also made use of the CV2 module, which is simply a module that helps you make use of OpenCV, then NumPy, which is very popular. So my main need for them is one, to calculate the range of colors that we have here, and that of the OpenCV is to be able to convert our color into a mask that we can make use of. It's an HSV that we can now mask from those values. So initially I initialized my variable, that's the proportional gain, the integral gain, and the derivative gain. And I also initialized a way to scale it. This scaling is just an increment on the velocity. So because I was going to be increasing the velocity, I felt it would be more efficient to also increase each and every one of these. Although I think a direct linear scaling is not really the best way to go about this, and I was actually reviewing how to improve each and every one of these scaling, because currently they are all scaled linearly. So I don't really think that's the best way, because it was not responding in the best way. But since I'm running out of time, I just felt I should implement that so I can move on to other tasks. So initially I scaled them linearly. Then my previous error, I initialized that. My error somehow also initialized that. So this is just a simple calculation of the range of our colors. You can see this list here is simply a list of RGB values. Our normal RGB colors. The same thing with this other one. So this is like calculating a range of red color, range between the color we are going to be detecting. Okay, so then this, like I said earlier, we are simply looking for a wait, let me quickly adjust display so we can see the vehicle as it's moving. Okay, the vehicle is still on track. Okay, so what I'm simply doing here is that I'm converting the image into HSV, and then from there, that's HSV color. HSV color are very better when you want to use them for segmentation reasons and stuff like that. So I'm now converting that value into a mask that I can now make use of in this in the calculation of the contours. So what are quarters? Quarters are just like boundaries, like the normal definition of quarters. When you look, just simply boundaries that you can determine, oh, okay, this is the boundary I'm to follow and stuff like that. Like as you can see in this display of the vehicle's movement, you can tell that it's always positioning these green dots. You will see where I implemented these green dots soon enough. So it's always looking out for the boundaries and trying to maintain a line between the two boundaries. Okay, let me adjust this. Okay, okay, okay. So from this, we we process the largest color, and then in that large color, we can now look out for the center of it. In the documentation I looked up, it was referred to as the centroid. But what I'm basically doing is I'm looking out for the largest color I can find, and then let me zoom this. Okay. Okay. So I calculate the center of the largest color I can find, and then anytime there is a kind of shift, I simply compute the error of it, then I append those error changes to their initial value, create an error sum, and simply update the other variables with it. Then here is simply just a way I set the angular velocity to improve the way it moves along curves. Then this is the velocity itself, which I'm also scaling. So currently for my initialization, which is 2, and times in this simply means our velocity is running at 2 constant value. I also looked up making the velocity dynamic, so like it will reduce when it's going through curves, but it was taking a lot of time because I was finding it difficult to understand some concepts. If I happen to have had more time, I guess I would have been able to implement that, but like I said, I'm running out of time, so I had to quickly record this just for initial proposal submission. Let me adjust this. Okay, then in this particular place was where I drew these green dots that you can see here. If you look at it, this RGB value here is simply just the green dots. If you see the green section of this tuple, the green part is the highest, where our R is 0, green is, so that's what it's doing. It's creating this green circular dot that is showing us exactly where the car is staring at in the center, and how it's able to adjust to make sure that it's positioning itself on the center, irrespective of the deviation it encounters by traveling through each and every one of the bends. So that's it with the cycle. Then in this last place, all I'm simply doing here is showing the image. That's this particular image you can see here. So this was very efficient because initially I was finding it difficult to detect how the car was perceiving its front, how you could see the front. but this came in handy when I was trying to debug and adjust how the car was behaving with respect to curves. So that's it. That's like a walkthrough of my implementation. Now let's just wait for the car to run completely. So stop it when you complete one lap. Okay, that's one lap. So stop. Okay, so that's my recording for this. Thanks.